Okay, I'm going to show you how to do these probabilities by hand, well, by using a table. But when we have a probability, for example, the probability that z is less than or equal to 1.58 in a normal distribution, hold on, let me get my in a normal distribution, the mean is going to be right here. So what we want to know for the first one is the probability that z is less than or equal to 1.58. So a little bit 1.58 standard deviations above the mean. So what you can do is you can go to your table and let's go to the positive table, and you go to 1.5, and then you go to 1.58, and it's 0.9429. So what that means is the probability of 1.58 that is all the area up to 1.58. So anything less than or equal to 1.58 would be 0.9429. So since we want less than or equal to, when we look it up on the table, the number we get is exactly what we need. Okay, so for the next one, z is less than or equal to negative 1.21. So for this one, we would go to our table and go to the one with the negative values. Negative 1.21. Negative 1.21 would be 0.1131. So if I were to draw my table here, here's the mean. Negative 1.31 would be, let's just say, about right here. So the number that we get, the probability that we look up would be all of the probability of less than or equal to negative 1.31, and that probability is 0.9429. So this is exactly the number that we want for this one. Okay, so if it's less than or equal to the number, then when you look the area up under the curve in the table, it's going to give you the exact value, the exact probability of less than or equal to that z-score. Okay, so let's look at the next one. And this time we want the probability that p is between, the probability of z being between negative 0.88 and 1.79. So negative 0.88 and 1.79. So what we want is, let me do this in black here. So here's the mean. So we want the probability that here, let's say negative 0.88 is about over here, and then 1.79 is somewhere over here. We want the probability of in between these two numbers here. So what we have to do is we have to get the z-score for this one and the z-score for this one, okay? But when we get the z-score for 1.79, it's going to include everything, okay? It's going to include everything. But what we really only want, let's see if I can get this to change here. But what we really only want is everything in between here. So what we have to do is get the z-score for this one, and then the reason we need the negative 0.88 is it's going to give me this everything right here. So when I get the negative 0.88 z value, the probability, I can take this probability here and subtract out the part we don't want, which is this right here. And once I subtract it out, that will give me the probability of the in-between. So basically, I want the probability of this number right here, but I don't want this little part over here. So if I know this little part over here by looking up this, I can subtract this little part out. Okay? So let's look up those two numbers. I've already looked those up in your table. You can go look them up, but this number is going to be, I believe, 0.1894, and this number over here is going to be 0.9633. So what that means is the area from here all the way back is 0.9633. But I don't want it all the way back. I want to stop right here. Okay? So to stop right here, I need to get rid of this area over here, which is 0.1894. So if I take 0.963 and subtract out the point I don't want, 0.9633 minus 0.1894, I believe you will get 0.7739. Okay, and that's basically what you do. You find the probability for both of them and subtract out the bottom half that when you're wanting to find the probability of it being between these two values. Okay. And then for the last one, it's basically the same thing. Here's our normal curve. Here's the mean. We have the probability that it's 0.3. Let's do this. That's the mean. Let's do the probability that it's between 0.33, which would be somewhere above its positive. And then let's say 2.17. Let's say it's somewhere right here. I know that's not the best picture there. So if I go look up the z-value associated, the probability associated with the z-value of 2.17, I get 0.9850. But remember, that is the probability from here back. Okay? So that would be a good number, except I only want from here to here, right? So I've got to figure out how to get rid of from here back. So if I look up 0.33, if I look that up in my table, whatever I get is going to be the probability from 0.33 back. Okay? So if I look that up on my table, it looks like it will be 0.6293. So 0.6293 is this area from here on back. So anytime you look up the number, what that probability is from that point all the way back to the left of it, okay? So if you take 0.9850 and subtract out the 0.6293, then you will get the probability between 0.33 and 2.17. You will get 0.3557. Okay. Let's see if we can move on to another problem. I'm not sure if we have time, but this one is going to be a little bit... Okay, this one, z is greater than 1.41. So here, if you go to 1.41, first of all, here's your normal distribution. 1.41, let's say, would be somewhere right there. If you look up the z-value associated with 1.41, let me see if I can find that real quick. 6.22. I believe it's 0.9207 is what you'll get. Now, that's the probability of it being less than or equal to. Okay, that's all of this. But we want the probability that it's greater than that. So what I know about probability is the whole curve has to add up to 1. So if I know that this is 0.9207, how do I figure out what the rest is? Well, I take 1 and I subtract it. So if you want to know greater than something, you say 1 minus the probability of what you get. This is the less than part. So if you want the greater than part, you want this side, right? Okay, well, we know they have to add up to 1. So 1 minus the other side would give you the answer. So you get 0.0793. Okay. Let's see if we can do just the part B on this one. Z is greater than negative 0.33. So here's the mean. Negative 0.33 would be somewhere over here. Now when we look up in the table, it's going to give us the probability of it being less than or equal to, or the area under that. So when I looked at negative 0.33 up, I think I get 0.3707. So that means that the probability of it being less than or equal to this part would be 0.3707. But I want the probability of it being greater than. So I know this red plus this yellow would have to add up to 1. So I know that 1 minus the other side would give me the probability of the greater than side. So if I do 1 minus 0.307, I would get 0.6293. So if you want the less than side, you just look at the table. But if you want the greater than side, you have to look at the table and say 1 minus the left side probability.